So UnityGod writes, give us a tutorial on generic characters. And he goes on to explain that he would mean something like this dinosaur. So, yeah, why not, right? Here it is. Here's the dinosaur walking around. He's got an idle cycle. He's got a walk cycle. He moves left, right, up and down. This is kind of like a 2.5D platform character is what I was going for here. And the camera is static in place. So if you want to see how this is made, continue watching. The code is it's like less than 50 lines of code to make the controller for this. But there's some caveats because this is a character that was made before Mechanim, so we get around some of that stuff in this video too. So I'm going to try doing this from scratch the best I can. And, hopefully this video is only going to run like 10-20 minutes tops. I'm using Unity 5.6 beta. Shouldn't matter too much, whichever version of Unity you need to use. Going to a new project. I'm going to call this DinoController. Create. Okay, so I'm going to pause it while this is creating a blank project. And here's the project. First thing I want to do is import the asset. Now you could click that open in Unity button, but mine, for whatever reason, does not work. So I'm going to go to Window and then go to Asset Store and search for it. And there it is, first result. It's free. I'm going to click Import. And this will take a moment. Import. I'll pause this for just a second. One thing to note about this import is I saw some standard assets come through. If you do actually use this dinosaur, there's some stuff you can delete later. But more on that later. And there goes by the standard assets, the image effects, those kind of things. Maybe used for a demo. But in this case, we just need the character. So it just finished importing. We have a folder now called Allosaurus. And so we're going to go ahead and start making our scene. So let's import the Allosaurus. So Allosaurus folder, prefabs. Looks like there's a couple versions. I'm going to go with the first one. Drop it into the scene. I'm going to center it at 0, 0, 0. And hit play to see what we get. Now we can see an animation already on this character. He's got kind of a cool walkie animation. And if we look on the right in the inspector, we can see that it's got the animation attached to the character directly. This is the pre-Mechanim way of doing things, so we're going to do it differently. So we're going to get rid of that first of all. So when you play it from this point, it shouldn't move at all. It should just stand statically the way it is, as you see here. So the second thing is I'm going to build a floor to give it some context. Something like that looks pretty good. And then I'll build a block in the background to give it a little bit more depth. How about a sphere? That works. Cool. Dinosaur Planet Nebulon. Alright. Nice. So those things are in place. I'm going to save my scene just in case because my stuff crashes occasionally. Call it scene 1. So the first step is I want to make it so our dinosaur moves when I press the keyboard. So picking the dinosaur, I'm going to add a component and put a new script on it. Call it DinoController. Create. And open that in the editor, which is over here. There we go. Make this a little larger. And so the first thing we want to do is capture, we're going to make them walk. So first thing I want to set up is a float. We're going to call it walk speed. And set that to public. I happen to know that 5 is a pretty good speed. Now down here, the first thing we want to do is capture input. And then we want to translate the character based on input. And then we're going to rotate the character at some point. But first, let's capture the input. So float h is going to be get our input dot get axis. horizontal. And then we're going to do the same thing for V. So V is going to be vertical. We're going to need one more value too. We're going to call this walk delta. And this is going to be our walk speed times time.delta time. And we're going to need that to make our translation smooth. So with those three values captured, we can start to be able to write the behavior for how it's going to walk around. So transform dot translate. So this is going to move the character based on the translation, which is essentially like doing this, kind of doing this and dragging the character's values around. So if you're translating on the Y, you're doing that. If you're translating on the Z, you're doing that. So in the code, to get those values, we're going to derive them from a vector 3. So we're going to say vector 3, add a little space here. Vector 3, we're going to call this one vector 3 H for horizontal. And this is going to be a new vector 3. Oops. Vector 3. And so this is going to be movement on the X value. So it goes horizontal, right? So we're going to need basically H times, oops, we're going to need our H value, which we defined up there, times walk delta. And then we don't need it to move in the Y or the Z axis. So that takes care of horizontal movement. Now the vertical movement, we're going to have to do something very similar, except we're going to do our little equation here and move it over. We're going to leave x 0, we're going to leave y 0, and we're going to move it to the z. So this is going to be moving forwards and backwards towards the camera, away from the camera. One more thing to note is we want all this movement to be in world space. So we're going to do, we're going to define that down here basically. So translate, we're going to do v3h, and we're going to do this in space.world to define world space. We'll do the same thing for v. So let's give this a play, make sure we don't have any errors or anything, see what happens. Okay, so with it running and tapping the left and the right keys on the keyboard, I'm getting the movement I want out of it. Now, the first thing to note is that it may not be looking right. Like if you're pressing up, it might be going left or down, right? This is going to be relative to the character's default position in world space. So you've got a few options here. You can go with what's written there, or you can tweak the code, or what I like to do is make it so it makes sense according to the inspector. So when I press right on the keyboard, I'm expecting that he's going to move in a positive direction on the x-axis. And so when I'm pressing right, he is in fact doing that. I can see the value going up in the inspector. When I press left, it's going back down again. For vertical, those values should be doing pretty much like the same thing. They should be moving relative to each other. We try that. That looks good. That looks good. So although those values look good, he's moving kind of the opposite I think you should. So the easiest solution to this is probably going to be just to go V and H. Save that. Rerun it. And now when we play it, clicking on the game window to make sure your keys are locked in. When I'm moving left, he's moving in a negative direction the way I want. And when he's moving right, it's moving in the expected value. When I'm pressing up, see, he should be going the other way, and when I'm pressing down, it should be the other way as well. So to tweak that value, you can take the negative version of V. Now what we're doing here is kind of how you can do this quick and dirty by tweaking some of these values like this to get what you want out of it. You could sit here and refactor this if you'd like. That's totally cool too. But we're just going to keep rolling here. So now he's moving the way we want. So once you have it moving well, in my case, when it's moving consistent with the inspector values, then it's time to add your camera. And in this case, it's going to be a stationary camera. So that's kind of why we're approaching it from these options. So with the camera selected, we're going to translate it to move it towards a viewport that looks good with our controller. Something like this, perhaps. Pan that out, bring it up a bit. Yeah, let's give this a try. So same thing, clicking Look, this looks good. This is moving relative to the controls that I have. It's moving pretty smooth. You can also come in here and adjust that value we talked about earlier. I have it set to 5. If you set it to 1, you can see where he's going to move real slow. It's almost kind of choppy, really. Crank it up to 20. Shoom, you got caffeinated raptor. So we're going to drop that back down. I say it was like a 5 or something. Yeah, 5 felt pretty good. So back to 5. This camera position I like. This is still in play mode, so I'm going to go to the camera in play mode in the inspector, and I'm going to copy the transform component. And then when I stop this, I can go back to my camera and, of course, paste the values over the top of the transform. So now we have the camera angle we want. I'm going to save again. So that's the first major step, is to get your character moving around the screen and mapping your input to translations. The second thing I want to solve here is when you move left and right, he's not flipping. You know, he just always faces left. So the way to do that, one way to do that, is to look at the value of the H on the controller, the horizontal value. And if you take that horizontal value, you can determine, based on its positivity or negativity or 0, which direction the character should face. So essentially it goes like this. If H is not equal to 0, so control is moving, while control is pressed, update direction, float direction. This part is kind of a little bit wacky, so I'm going to type this out and then we're going to walk through it. How about that? Okay. So basically direction equals horizontal. If horizontal is less than 0 as a question, basically then say return 0 or the value is going to be negative 180f. You take the value of that and then transform dot rotation, or excuse me, local rotation Quaternion, Quaternion. That one always gets me. You know, in situations like this, I know people are like, "Why don't you use autofill?" But you know, honestly, I'm just trying to I'm trying to learn this stuff better, and by having to type it, I end up learning more of it. So anyway, little thing aside, so float direction equals, this is a ternary operator that lets you just type an if statement really tiny. So it's basically looking at it and basically saying, if H is greater than 0, oh, face it this way. If not, spin it 180 degrees. So with that in place, let's give this a try. And we'll look to see if our dinosaur is turning correctly. There he is. Now he's doing the exact opposite of what I want him to be doing. So this is another situation where you can either punt on the values or you can start playing with these kind of operands to get what you want out of it. I'm just going to tweak values. Looking good. So now we've got the dinosaur turning around, facing the correct direction. Clipping through things as expected. Right, and so that's how you can solve the looking left, looking right quickly. You can certainly write this to be a lot more robust. There's a lot of ways to solve this problem. You really don't need to do this rotation every single frame. You can use a flag to stop that, but we're not going to digress. This is a very basic tutorial. So we've got the input mapped. We've got the character now moving around the screen. We've got the rotation of the character correct. The last thing we're going to do is add the animations back into the character. And so this is slightly more complicated than it would normally be, just because it's an old character with old style animations that are legacy animations. So here's what we're going to do. First, we're going to build an animation controller. So over here in the project, I'm going to right click, go to create, and then I'm going to go find animation controller, and we'll name it Dino. Cool. So now we go back to the dinosaur. We're going to add component. We're going to add an animator to it. Not animation, but animator. Under the controller property, we're going to click that and go to Dino. And now it's been associated to our dinosaur. Our dinosaur is rigged with an animator. So let's double click on the animator and in the Animator Controller here, we're going to add our two states. We're going to have a walk state and we're going to have an idle state. So right-clicking, I'm going to create state empty. I'm going to do the same thing again. Create two empty states. The first state in the inspector on the right-hand side, I'm going to rename this to idle. The next one I'm going to name walking. And we're going to set up some connections. So I'm right-clicking, clicking making transition. So this is going to be the transition from when you're idle to walking. And I'm right-click walking, make transition from walking back to idle. Now the way these states are going to switch is through a parameter. So on the left-hand side, I'm clicking parameter, clicking this little minuscule arrow and clicking bool. And I'm going to call this is walking. Keep in mind these are case sensitive. So with this defined, I can then specify some rules down here between these two parameters. So when you're idle, going to walking, I click that arrow, it turns blue, and on the top right hand side you can see the conditions. Right click that, or excuse me, left click that plus arrow, look for the is walking condition and set that to true. Same thing for the other one except slightly different. Left click it, go to conditions, go to is walking and set this to false. So now what's going to happen is whenever something is in the idle state and that value turns to true, it'll pop over to walking. And then whenever something's in walking and that is walking turns false, it goes back to idle. So there's a few more things we need to configure with this relationship before we can start testing it. Left click on the idle state. There's a few things to note. Right now we haven't specified an animation yet. So if you go into the dinosaurs folder, the Allosaurus, and then look for the Allosaurus folder inside of that, and then look for Anams is the name of the folder. Short for animations. Look for Allosaurus idle. So check this out. If you left click this, and normally you would just drag and drop the animation into the motion, you're going to get an error in the console. Let's find that real quick. And the console says legacy animation clip cannot be used, and legacy animation clips are not allowed, essentially is what it's saying, inside an animation controller. I'm not sure why, but you can kind of get around some of this, sometimes at least, if you click on the animation itself. So we're going to go back into the animation, back into the folder, back to idle, and in the inspector, to the right of the tab, there's what I would affectionately call the hamburger icon menu. Click that, left click, and look for debug. Click debug. You're going to see some extra information here, and there's a checkbox that says legacy. Unclick legacy. Do the same thing for the Allosaurus walking animation. The debug's already going to be on. We're going to unclick legacy. So now we're going to be able to go back to the controller, click idle, and then notice this still looks wacky. I'm going to change this back to normal again. I'm going to drag idle into the motion. You'll know it works because it'll say Allosaurus idle next to it when it works. And it should have that they're no longer tagged as legacy. Walking, same thing. I'm going to drop that in place. Okay, so our relationship set up, the animations are set up, but we have a little bit more tweaking to do here before this really works right. First thing we need to do is look at both animations and make sure that they loop. So this is the idle animation I just clicked on in the inspector. I'm going to click loop time and I'm going to click loop pose. And then the same thing for walking. Left clicking that, loop time, loop pose. So that's going to make sure it doesn't play through and stop. It's going to keep going. Second thing we need to do is on the transitions from idle to walking, there's this has exit time. I'm going to unclick that. Same thing for the other transition. Unclick that. And what that's going to do is make it so whenever you stop or whenever you begin, it's just going to go right to it. It's not going to wait for the whole animation clip to play before transitioning to something else. Alright, so we did a lot of configuration there. We're just going to have a look at our dinosaur, make sure things are looking good. Animation controller's hooked up. There's no avatar specified, but that's fine. Let's look at the animator window down here. And we're going to give it a play. And let's have a look at the relationships of these things. Now, it's not going to walk yet. At least it shouldn't. We're going to look to see if the animator is working. Now, this is what to note. This idle thing down here is ticking away. This little blue bar basically says it's playing through the idle animation. It gets to the end, just keeps wrapping it. On the left-hand side, we can see the is walking parameter. If we check that box, you can see it just transitioned to the walking animation, and now our dinosaur is walking. It'll continue to walk like that until that box is unchecked, until it's set to not walking. And then it transitions right back to the dinosaur idle again. So we've got our animator configured. Now we're going to go to the code and queue this up and make sure it works the way we expect it to work. So we're going to save. I'm even going to save project just in case anything went haywire. Now in the code, under update, this is a good place to look for this. Essentially, we got to do a few things here. I'm going to say, we'll put it right before rotate. This is going to be update care animation. So the first thing we need to do is we have to access the animation controller. Get component animator, and then set bool. Set bool is going to let us modify this is walking value, and it takes two things. First, you pass the value name as a string, so is walking. It has to be spelled exactly the same, case and all. And then you set a true or false at the end of it. In this case, I'm going to put walk state, make it a variable. So walk state right here is going to be set to bool. In walk state, we're going to look to see if the character is actually still moving, essentially, through the script. So you can tell it's not moving because there won't be any input on the V or the H. So you won't be pressing left or right, you won't be pressing up or down, and during that time, that's when it needs to be idle. Yeah, I'm going to pause this for just 1 sec. Sorry about that. Okay, so in order to get the value of is walking, like we said, we didn't want to make sure that there's no horizontal and no vertical going on. So to figure that out, you can look at the values of V, you can look at the values of H. So if V equals H, now the only time V could possibly equal H is if they're both 0. You can't get this, it doesn't work. Basically, that works. You can say if V is equal to H, that would mean that the character is idle. So the word walking state is actually a little bit misleading, but we're going to put this negative, we're going to put this negative symbol in front of it, which means invert the value. So basically it says, is the character idle? Well, invert that, which basically says, you know, it's false, they're not walking. Hopefully that makes sense. So with that value, we pass it to the is walking bool in order to control the process there. So when I play this, what we're going to see now is that the dinosaur is idle, everything's looking good in the graph, and then this little bit of code here keeps checking every single frame to see if I'm touching anything on the controls. So if I am, and I press left, for example, it's not going to do anything other than transition to the walk cycle. You can see at the bottom of the screen because now I'm walking. Every time I stop walking, I'm not pushing any input, it returns back. Same thing with the other side. So anytime there's a button pressed, the walking is going to go on. But anytime I let go, the idle happens. And so that's the gist of how to take that character and animate him in a certain way. I think the trick to asking a question like, can you do a generic controller, the first question you got to determine in your own mind is, what kind of game am I going to make? Where's the camera going to sit? Those kind of things. Because some of the methods I'm using here are assuming that your camera is going to sit 2D, 2.5D style, look at the character the whole time. So I'm able to make a lot of assumptions about how I want to move the character. So I'd say before you try to write anything, it's good, just general advice. Put it on paper a little bit, mull it around, see if it makes sense, see if you can describe it in abstract, and then sit down to code it, because there's a lot of ways to solve these problems with player controllers. This is just one implementation, and it's not optimized. But if you're just playing around, you want to make something in a jam or something, I mean, we're talking like, 50 lines of code or something, you get kind of a fun controller going. It's not bad. So there you go, UnityGod. Hopefully this helps you explore Unity more, and takes you one step closer towards making the characters that you want to make. And I think the takeaway too is that hopefully you kind of understand that it's more about the controller that sits on top of the character rather than the character. You could swap this dinosaur out for a totally different character, and a lot of this stuff will be transposable to that other character. That was the gist with the Ethan MCS tutorial stuff. It's really a system that's going on top of a character rather than the character. It has to be modeled a specific way. So that's about as generic as I think I can explain it. Hey, thanks for watching, and see you next time.